They actively drink the excess groundwater, naturally depressing the water table back to a survivable level.
Now, if we connect this to the bigger picture, it reveals an incredible paradox in how we use technology.
How so?
Well, earlier we established that modern tube wells were a massive threat, right? Because they aggressively suck up groundwater and drain the aquifer.
Right, the giant industrial straw.
Exactly. But when fighting waterlogging, the government actually installs thousands of tube wells, specifically to act as industrial drains.
Wait, really?
Yes, they use them to pump the stagnant water out of the swamps to artificially lower the table.
Wow. So a machine that destroys the environment in one province is the exact tool used to save it in another.
Exactly. It's an endless game of whack-a-mole.
And speaking of whack-a-mole, the farmland isn't the only thing under threat. If we look upstream at the infrastructure itself, the dams are fighting a losing battle against what is physically suspended in the water. We really have to talk about siltation.
Siltation threatens to undo the entire Indus Basin project. And the mechanism for it actually starts far up in the northern mountains.
Deforestation, right?
Yeah, deforestation is the catalyst. When you strip the mountainsides of timber, you remove the complex root networks that act like a structural net, holding the topsoil to the rock.
So when the monsoon rains hit or the snowmelt accelerates, there is nothing holding the mountain together anymore.
Nothing at all.
The water just violently washes thousands of tons of loose dirt, gravel, and rocks straight into the fast-flowing rivers.
And water velocity dictates exactly how much sediment a river can carry. As long as the river is rushing down a steep gradient, it carries that mud slurry easily.
Like a conveyor belt.
Right. But the moment that turbulent river hits the stagnant, still water of a massive dam reservoir, the velocity just drops to zero.
Oh, I see.
Physics takes over. The heavy silt immediately falls out of suspension and settles right on the bottom of the dam.
Which triggers two massive engineering headaches. First, that suspended grit acts like liquid sandpaper when it gets sucked into the hydroelectric turbines. It just erodes the incredibly expensive machinery.
It just tears it apart.
Yeah. But second, and honestly far worse, every single ton of mud that settles on the reservoir floor displaces a ton of water. Year after year, the reservoir literally fills up with dirt. It loses its storage capacity.
Meaning the dam can't hold enough water in reserve for the drought season, and it has no empty capacity left to absorb a flood surge during the monsoons.
It basically loses its primary function.
Exactly. Now, they try to mitigate this with afforestation, planting trees back on the slopes and building smaller silt traps upstream.
But my absolute favorite pragmatic detail from all of this, from the sources, is the ultimate brute force hack.
Oh, building the walls up.
Yes, because dredging a dam is incredibly expensive and logistically a total nightmare. So instead of scooping the mud out, engineers sometimes just build the concrete walls of the dam higher.
Just making the bowl taller.
Yeah, they just make the bowl taller so it can hold the mud and the water. It's such a desperate Band-Aid solution, but it shows how absolutely vital that storage capacity is.
It buys them a few more decades, but it doesn't solve the underlying disease at all.
No.
And that disease of contamination only gets worse as the water flows out of the mountains and down into the populated plains. By the time that water reaches the coastal megacities, the pollution problem shifts from mud to severe toxicity.
Right. If you look downstream at coastal areas like Karachi, the beaches and harbors are just taking a beating.
It's really severe.
You have millions of gallons of untreated domestic sewage and highly toxic industrial effluents from factories being dumped straight into the marine ecosystem. Not to mention the oil spills from the shipping ports.
Yeah, the urban footprint is massive.
But one of the most insidious forms of pollution actually comes from the farms themselves. The eutrophication loop is just brutal.
It is a textbook example of a cascading biological collapse.
Yeah.
Farmers apply heavy chemical fertilizers to boost their crop yields, which makes sense. But crops can only absorb so much of it. When the fields are flooded or heavy rains hit, the excess nitrogen and phosphorus just wash into the drainage canals and eventually into the lakes and rivers.
And fertilizer does exactly what it is designed to do. It turbocharges plant growth. But in a lake, it causes an explosive, totally unnatural bloom of algae on the surface.
Right. The water turns into this thick, impenetrable green soup.
Which looks gross, but the real issue is that algae mat blocks sunlight from penetrating the water, killing the aquatic plants below.
And the real devastation occurs when that massive algae bloom inevitably dies.
Because it all sinks to the bottom.
Exactly. As the algae sinks and decomposes, the bacteria feeding on it consume staggering amounts of dissolved oxygen. They literally vacuum the oxygen out of the water column.
Wow.
So the fish, and really the entire aquatic ecosystem, just suffocate.
And for the millions of people relying on that water for their daily lives, the consequences are catastrophic. This level of biological and chemical contamination is a direct pipeline to severe waterborne diseases, like typhoid and cholera.
Absolutely.
Which brings us to the ultimate, terrifying reality for this landscape. With a water supply constantly shrinking due to mud, poisoned by salt, and contaminated by urban runoff, the competition for the remaining clean water is basically a powder keg.
And if you look at the breakdown of who actually gets to use the water, the disparity is wild, and it explains exactly why the tension is so high right now.
It is an astounding metric. According to the lectures, around 94% of the available water goes directly to the agricultural sector.
94%.
94%. That leaves a measly 6% to be divided among every single household for drinking, cooking, and sanitation, plus every single factory and commercial industry in the entire country.
When one sector holds an absolute monopoly on a scarce resource like that, internal political conflict isn't just likely, it is guaranteed.
Yeah, you have booming urban populations demanding clean drinking water and a growing industrial sector demanding water for manufacturing, all fighting over a 6% sliver of the pie.
And the friction isn't just between sectors either. It is intensely geographical. It pits province against province.
Oh, completely.
The debate over the proposed Calabar Dam is the perfect case study of this kind of existential dread. You have the upstream province of Punjab and the downstream province of Sindh, and they are basically locked in a standoff.
And it is crucial to understand here that neither side is acting irrationally. Both provinces are operating from a place of absolute survival. The geography literally dictates their politics.
Exactly.
Let's look at it from Punjab's perspective first. Punjab is upstream. They are the agricultural powerhouse of the country, and they desperately want this dam built. From their point of view, millions of acre-feet of fresh water are just flowing past them and dumping into the Arabian Sea every single year.
They see that as a catastrophic waste.